Good evening, everyone. This is Chetan Mughal from BIM Engineering US. I'll be conducting today's webcast on Introduction to 4D BIM. So today is going to be a very brief summary of what 4D BIM does. It will start with a brief introduction about what BIM 4D is and how it ties into BIM. But before we get into the webcast, we want to get into what we're trying to do here. I'm basically a speaker for NIBT, which is National Institute of Building Technology. The goal here is really creating a more futuristic platform for construction related, construction management, construction skills, construction technology related, information center, curriculum center, education center, case study center, basically big resource for helping grow into the next phase of construction industry. Basically, the focus of National Institute of Building Technology is to really not trying to create a skilled labor, but get into a skilled professional where people are more entrepreneurs, open mindsets. The organizations are more open, so it focuses on management on that level, where it teaches organizations to be more entrepreneur oriented or much more open-ended with their workforce. And same vice versa with the workforce. They want to push more broader perspectives into construction management using modern technologies, lessons learned, and things like that. I have been doing this for about 15 to 20 years now, primarily 15 years right now into specific BIM technologies. Started with my Virginia Tech. I have a master's degree in construction management, currently doing my business administration from Harvard. I've been on the speaker series for smart cities in India, in Delhi last year. My focus will be talking more about developing a more structured educational environment, learning environment, not only just during engineering courses, during our undergrads or bachelor degrees, but also going into more career paths during the process of our professional careers. Management is going to be our biggest push because we believe that that's where we struggle. A lot of talent these days we have is around skill, and not much is focused on communication, negotiations, and things along those lines, which is, to me, is the most important part of running a business. Going into our company itself, to give you a quick background, we provide cutting-edge building information modeling solutions and consulting services to supplement traditional project delivery methods with a very technology-driven process in the construction industry. So that's our skill set. We work around the nation. We haven't worked outside the United States yet. That's not going to be our primary focus. Our focus is primarily in the United States, but that's really exciting. So it's been going very well for us so far. So jumping into the agenda for today, as I was explaining earlier, our course is going to be focused on these 5 bullet points. Where does 4D fit in the WWW, which is World Wide Web of BIM? And I'll get into the why and how I'm trying to relate World Wide Web to BIM. I will be talking more about what is 4D, trying to understand our listeners, trying to give them a better understanding of what 4D means, then the process of putting together a 4D model. So we won't get into softwares and how they operate and tool sets and things along those lines, but we'll basically give you a generic idea of how a 4D is put together. Use cases for 4D BIM and model. So where is 4D BIM more useful, where it is used now, what is the perceivable future, and things along those lines. BIM equals 10% software plus 90% sociology, which is people skills. I think where we're going with this is, you'll see me repeat this point, because knowing a software or knowing a tool is irrelevant. So it is relevant to a certain degree, but just because you know a software or know a tool doesn't mean that you are BIM trained. 90% of the work that I do is not in software. It's about communication, conducting meetings, running analysis, working with teams, collaborating with teams, working on schedules, budgets, you name it, or everything that would or would not include a software. Okay, so that's basically the concept of BIM. BIM is not a software. It's not a tool. It's not a software. It's a process. It's a workflow. Yes, software does come into the play, but it's not as big as you can see. And that's been the common philosophy even in American General Contractors Associations and most of the elite members who practice BIM. That's been the general philosophy that we try to put forward. So that's our agenda. Going forward, let's get into the first topic, which is where does 4D fit in the World Wide Web of BIM? So let's first understand what I mean by World Wide Web. Right? I explained that in the last webcast that we did last week. Basically, what is BIM? My BIM, if you really think about it, is like a World Wide Web. It's internet. It's softwares that make internet. It could be databases. It could be websites. It could be softwares, plugins, widgets. Social apps. Plugins, connectors, pop-ups. You can keep thinking about any creative way you can think of creating or using a World Wide Web, and that encompasses everything, including managing of people who can develop the softwares. Right? Technology companies have a lot of workflows and processes, and there are people who just do processes, and there are project managers to manage those processes only. Right? So workflow analysis, there are waterflow analysis, there are agile processes out there. So there are multiple types of processes around World Wide Web. We don't even talk about softwares. We do sometimes. We talk about PHP, Java, .NET, you name it, iOS these days is coming, but these are all the softwares. But anything that you have to put around it is, you can realize quickly that it's just not the software. So that's what we're trying to, that's the point we're trying to make here, is basically BIM is not a software, it's a World Wide Web. You can think about anything, information that is embedded into what you see goes in all directions. So quick definition, I'm not going to go through the definition of what BIM stands for and what it is. Somewhere here you will see we talk about 4D, right? And we talk about integration of time with 4D. In the future webcast, we'll get into the NDs and the 5Ds and how the cost and everything works. But today we are just going to focus on 4D aspect of the BIM. So if you have any questions, you can always email us. Right now, because we're trying to run this webcast through, we'll be doing it quick, and we'll be more than happy to return to your questions later. So that being said, let's jump into the next question, which is what is 4D BIM? In concept, a 4D BIM is basically a 3D integrated into a schedule. Okay, you'll always see schedules made in some sort of a charts, and this plus this is 4D BIM. It does not include any cost, not necessarily, or not applicable, I would say. You can always include a cost in 3D model, but the concept of 4D is not to use the cost analysis. We could. And 6D, which is ND, people like to call it because it goes into multiple directions. We're not going to talk about it. So 4D is essentially 3D plus a schedule connected to it. Okay. And remember, we always expect 2D is not BIM. There is no concept of 2D BIM, and a lot of times, even the 3D, when it comes to using a vector-based softwares or what do you call this? Parametric-based modeling, non-parametric models are also not BIM. So if you can see, a lot of 3Ds can be done in a lot of other softwares, which are 3D Max, or call it AutoCAD itself has capability to do 3D, but they're not necessarily, they're not BIM, they're not BIM because they're not parametric models. Okay, so just want to make sure that I clear that point. So now we understand what 3D and schedule is, right? So we've all seen 3Ds before, and this is what a typical 4D model will look like. right? And how we're talking now about how is a 3D connected to a schedule. So basically what happens is you have, and I'm going very basic level, is you have a 3D model, right? You have a 3D model, and the 3D model here and here are connected to the schedules, right? These are the schedules on the top, you can see them. And it has every single line item, as you can see. These are all line items in the schedule, which could be pour foundations in area 1, 2, and 3, pour columns, pour beam, install wall in east wing of the building, living room, install light fixtures in unit 1, 2, and 3, bathroom fixtures, could be anything. Those are the schedules. So when a schedule is made, it's basically a timeline of how the project is going to be constructed. And if you're in the construction industry, I'm pretty sure you are vaguely aware of the concept of scheduling. So scheduling is the most important part, or most important tool that we have seen in the modern construction industry age, that has been used explicitly to make sure things are planned before they are built, and especially help monitor during the schedule or in construction phase to make sure that what we have planned is working out, or make changes as we continue. So we always have a more focused or more predictable deadline on when we can finish it, right? So that's really the schedule. It's a planning tool, and it gets really complicated as you get into complicated projects, and it needs to be complicated, because the more you plan, the more you think, the more successful the project can become. If you just want to go from point A to point B, it is easy to go, hey, tomorrow I'm going to travel from point A to point B. But if you plan to say, okay, it's an 8-hour journey, I will stop here, this is where I'm going to eat, I have kids traveling with me, so they need to do ABC, I'll do this. So if you're more planned, the chances of getting surprise, chances of getting into any crisis situations reduces significantly. And that's what better planners do. They plan and then they execute according to the plan. Now, plan can always change. It does change, as a matter of fact, in the construction industry. It does change all the time. The point is not the fact that we have to follow what we planned. The point is, now we have a plan, we can keep tweaking it, but now it's predictable of what we can do. Okay? So that's really the scheduling part. But what is happening is, as the schedules are getting complicated, and which they would keep becoming more complicated as they become resource loaded and cost loaded and things along those lines, what is happening is they're missing the element of visualization, right? There's a very famous saying, I'm not sure it's true or not, but when Apple invented PAM and they were trying to work on, John was the CEO at that point, they mentioned that they had a stylus, and we probably have seen PAM and the stylus, and the product failed. So one of the interviews, or one of the conversation between John and Steve Jobs was, hey, why Steve Jobs was very against the PAM and PAM itself, and he didn't like it. So when it was launched, Steve and John were conversing, and John asked him, why are you so opposed to the PAM? I mean, it was such a fantastic technology. And Steve responded to him and said, no, it was not. If you're using a stylus, you're not using the 5 that are given to you by God, right? They're on you. So the point is, people understand visuals better than loaded schedules with something that will look on the top here. So especially when they're not trained in understanding the schedule. So guys in the field, people who are not necessarily well involved in your planning, they can take days, and the fact that the schedules change every other week, it's very difficult to keep up, and just amount of resources that even a person who's supplying doors, that he has to understand the schedule, is extremely challenging, and the costs go haywire, the timings go haywire, because the door manufacturer not necessarily is looking at it because he doesn't really understand it. So he will or she will export the doors, or start scheduling the installation of the doors at the time where the schedule says something else. or it has been delayed, or it has been made urgent. So they don't see these things. So that's why the 4D is coming very handy these days. That's the primary reason why 4D is being pushed so much. The 4D is pushed because everyone wants to give a visual tool to everyone who is part of the construction process. So they don't have to depend on the schedule at the back end, which only few people who are trained in it understand. That's really the core focus of it, right? Is to plan, is to visualize, connect the visual. So the way it is done is, if you have an item here, for example, let's say we're pouring foundation, sector A. What they do is they connect this particular line item into the sets of the 3D. So you technically basically click on this, basically whatever the columns and footings are linked to that particular line item, and you say link. So you keep doing that. So it's a very daunting process. The way it is done is mostly the 3D model is converted into something called as sets, right? Which somehow equates to the scheduling portion of line items. So these are called activities. I'll call it activities here. So these are activities, and here's a 3D, and we call it sets here. These are sets, which is basically, you select all the columns that are on first floor as set first floor columns and call it set first floor column, and then you select an activity that is linked to it and you select that set, something along those lines. So that's how it is done. So it's a more manual process to find the right sets and link them to the schedule. The problem here, as you can see, is the 3D is the actual representation of the building itself. It's a virtual representation of the building. But the problem with the schedules are the way they have been done, and the people who have been trained in it is very different. They plan the project not by the resource. They plan the project by how the construction is going to happen, right? What it does is it defeats the purpose, because a 3D model sometimes is very resource oriented, which means it has elements which are concrete, doors, windows, color, paint, whatever you can put in it. But the schedule not necessarily has, it might say installation of a wall, but doesn't necessarily show all the wiring that goes into the wall. It doesn't understand that it needs to happen. So obviously we are adapting, we're changing, we're tweaking, but that's how it used to be done. More of people who are trained in it, how they're wired is how the construction happens, not necessarily the resource side. So if you happen to be doing this, if you're trying to use 4D technology, when you make a schedule, try to understand what the elements are and try to connect the two dots, and your success of a 4D application will be more efficient than what you might have seen in the past. And basically what it does is, when you run this clip and you play these videos, and I'll show you some samples in a second, when you run these clips and when you run these simulations, you will actually see the building getting built, and you can see this timeline going forward. The point is, you can run a timeline from this point to this point A to point B, and what it does is it allows a person to see what is happening that week. So if you're just installing doors, you can call door manufacturer, you can call the door installer and say, this is how we plan to build it. Here, this is where you will stock, this is where you will install, this is you understand how many people you need to move it, how many crews you might need. It gives that visual representation for people to plan. Okay, we're trying to install two different sectors of the building door, so I don't not necessarily need a crew, I might need two crews because it looks like we're running parallel. And that's very difficult to understand from a schedule, because it's just going to say install doors from start date to end date, and it becomes very difficult for them to understand that start doors meaning we're starting at 2 or 3 different locations at the same time. So it's a visual tool. From safety purposes, people can see, okay, where to stock things, what would be done by that point, so you can actually see what is done. In gray, anything that is getting built is typically shown in a different color. It's either blue or green. Anything that is in progress, sometimes that is getting built, is also shown by different colors. So the colors mean a lot. So anything that is, I think here anything that is gray is complete. It's complete. Anything that is like a navy blue color is in progress. And I think the lighter blue means something that is coming next. That's what it's trying to say here. So you can easily see what is happening next, what has already happened in these simulations or would have happened. So it's basically time travel. You can travel time and see what will be happening in the next 4 weeks and 5 weeks, and you can plan based on visuals, statistics from the jobs, and things along those lines. But that's how a model is put together. You have elements in 3D which are converted into sets, and then you have a schedule line item, which is activity, which is connected to the 3D. Moving on, uses of BIM, right? This is where I was explaining, I'll be showing you a video. So I was explaining the visualization and the benefit of visualization. Big benefit, because when you see things, when you feel things, you tend to understand more. As I said, pictures are more than 1,000 words. I think they express things more than 1,000 words, because you can see so many things in just a snapshot of a picture. So one of a famous person also says, a picture is worth 1,000 bricks. When you see something, you tend to avoid a rework, right? That's the whole concept of when he says a picture is worth 1,000 bricks. So if you see something, hey, don't do it. Let's plan things around it. You might save some construction time, cost, unnecessary rework, safety issues, things like that. So that's visualization is becoming a big tool. A parallel word which I prefer using around BIM is a VDC, and it's basically called virtual design in construction, right? VDC is virtual design in construction. You'll see that word being used more often when you start talking to people that relate to BIM, and when visualization being the most prominent word here, right? So that's visualization. That's the key of BIM. Why BIM is becoming so successful is because the visualization possibility. So project built virtually before actual, right? We are trying to build everything virtually. And remember, these are not concepts. These are real data points, right? A door or a window is going to be exactly with all the screws, fixtures, fittings, just exactly the way it is going to be manufactured. A lot of manufacturers are also printing things from BIM now. So because it's so exact, you can actually print a wall. You can actually print a door, right? So things along those lines, you can start getting into the concept BIM because it's so real. It's not just a fancy model for presentation and things along those lines, right? So that's why when we build things virtually before and you see what can go wrong, and sometimes we'll run the simulation and the manufacturer will come to us and say, listen, I know with this simulation you'll have 6 weeks of lead time for my flooring delivery, but you have a specialized flooring which is going to be made in Argentina, and it will take 6 weeks to just get here on a boat it's supposed to come. So there is no way we can match that. So we'll sit in the 4D meeting and we'll change the schedule based on their lead time, and then we'll see how it impacts. And the flooring it will suddenly change, and then the painter might come and say, listen, I don't want to paint before the flooring comes in because something will get damaged, I'll have to repaint. So let's change my pattern. So you will see a very involved conversation within your subcontractors, more intelligent. But remember, you're not spending any money. The wood flooring is not ordered, the paint is not damaged. Everything a virtual representation. So it's just the time that you're spending collectively to plan the building better before it is built. And this is becoming very huge, especially where time is extremely difficult to find these days. And same with finances, right? We want to make sure everything has to be finished with the budgets, and the budgets are getting tighter and tighter. The best part, the best way I can summarize it is really minimizes your risks, because you can plan so much, and if you were not planned before, and with the visual technologies and other things that you can put into place, now you can plan better and actually simulate a lot of things, which may make you more risk averse. And that's why the project managers, the construction managers are using this tool, because their job is to put everything in the budgets, finishing time, safe, and there is no other way to manage risk better than having a visual tool with you that can simulate with time. That's why 4D is becoming more prominent. Lean resource and cost planning. Again, goes into effective and efficient planning, right? If you can plan things, things will be leaner. If you are going to use 4 people, because of this detailed visual model, you can use 3 staff members to do certain work, because now there is a planning tool where you can manage the resources more effectively. You can manage cost. You can see how much money is getting billed every day, and that goes into more 5D standpoint where cost is connected to this. But simulations can be connected from budget standpoint. Okay, how much are we going to bill? How much are we going to bill from cost perspective every week, every other week? So the bankers are connected with you. They say, okay, let me make sure that I have the funds available for you. Let me make sure this is done. And it's very real, right? It's very real and it's very effective because everyone understands what is getting built. The cost of it is real because what you're building is what you're building. It's facts. There is no theories behind it, right? And then this is becoming the most important push, right? On-time delivery. When you have on-time delivery, or everything should be done on time as you plan, obviously, right? But when it becomes consistent and predictable, right? That's what we're trying to do. Make it more consistent and predictable. And when that happens, people tend to rely on you more because you can consistently deliver something around the time that you have promised, and you're predictable. It's not one project after one project is successful, the other one is not. No, it's predictable success. And because you can use this tool, there is more predictability, there is more consistency that you get in your companies or your careers. And obviously safety is the very big opportunity that can be enhanced from the use of 4D. As you can visualize what is happening, you can manage people, you can build safe environments around it, make sure before you put them into a place or call them onto the job sites, where they're supposed to work is planned earlier and it is made safe. So with that being said, I'll run a quick video, and I won't run a full video, but will be sharing these links with you after the webcast. So you can watch the videos. We'll be writing some articles that you can watch on our websites after the fact. So let me open this. Actually, I have it open already. So here it is. And sometimes the webcasts are a little shaky with the videos. So if you don't see them, with a smooth flow like a video should be, it's completely fine. We can come back and we can always give you a presentation of what it will be with the live video documentation that we're doing now. So you'll be fine. So as you can see, here are the sets, right? You can see in the video that the sets that you can get, right? That's what the person is doing. Those are the sets. Let's see here, the person has created the sets. Eventually it's going to link to a schedule, and that's how it will be done, right? You can see even the traffic can be managed. You can understand how the trucks are going to be. We did this project at MIT where we had a huge HVAC unit that had to be put in during, there was a hospital on campus that we managed around. So the way we had to plan it, we actually had trucks come in, we did a simulation, we presented to the client how we are going to bring in trucks, how the unit is going to be divided into multiple pieces, and how we slide it into the actual location. So the whole simulation had to be done because they were not convinced that we could execute it, and they were worried that the hospital might get impacted, and it could be a big mess if that happens. So we had to do a full simulation. We learned so many things because we realized some of the roads were not big enough for the turn for the trucks. We could backup. So we had to create a lot of analysis. So we had to actually remove some of this, small security offices and things. We had to demo them before we could bring the truck in. So because of the visualization and reality, we were able to see it ahead that those security cabins and things had to be demoed before we bring the trucks in, because they would not fit. Had not done that, we would be running in crisis. Last minute demo of the security offices. I mean, no one likes crisis, and that's where the money, frustration, time, everything is spent, and it's not worth it. So these are the simulations, and you can see how on the right screen you can see how the days, how the workflow around the traffic. You can plan anything. You can put traffic planning. So that's how a lot of linear projects where bridges and roads are built, they put traffic planning into place. So you can see a simulation of when you're building a certain place, how the traffic is going to manage. That is a 4D simulation of time versus a 3D, which could be roads and bridges along the line, how they will build. So those become very effective also. So it's not just buildings. You can put this technology to place in anything, even bridges or train stations, and you name it. So I think this video covers, so we'll be posting it online for you. So that's for sure. Let's go get into the software, which is the last slide basically before we get into the thank you note. So again, I want to repeat my statement here. Don't get stuck on the softwares, please. If you really want to get better at BIM, it's of course you need to know the tools, but the BIM is not, it's more than tools. It's more of understanding the processes, how to perform the processes in the right workflow, creating a planning guide, right? We'll be talking about BIM execution plans in coming future presentations. Those are the key things: how to plan, how to negotiate, how to write contracts, how to develop a team for BIM execution, how to create a workflow for your teams for work execution and things along those lines. What tools you can use, what resources you have, budget plannings, things along those lines. But anyways, let's get into this particular slide, which is basically these are not all. There are many tools these days out there, right? But these are the 3 things I keep seeing for scheduling, right? Excel, as always, we know it's always there for us, but as project, it's complicated. You can see, Microsoft has a very good package. It's called MS, Microsoft Office Project, and the product is pretty serious. It gets into seriousness because Excel can be daunting when it gets a little more complicated. It's not built for it. Project Schedule is really built for scheduling purposes. Oracle's project here, Primavera P6, when projects are really serious, they're complicated, 100% Primavera P6 is being used. It has a lot of potential for resource. Not that Microsoft is not used, they're very close, but I think Primavera P6 or other versions that have come out now, I'm not sure, tend to be much more used in the market when projects are more complicated. Okay. So that's from a scheduling standpoint. Now these schedules are connected to 3D models, and we don't have 3D softwares here. There are again plenty of 3D modeling softwares out there. And we'll get into that later. But the 4D integration tools. So the 3D tools out there not necessarily are capable of handling a 4D. Okay, so something we call it as authoring models. So the 3D modeling tools we call as authored models. Okay, which means you actually have to model or draw, as you might call it, in that 3D software. The 3D integration is more of a federated model. That's what we call it, which means you really cannot change a wall location. You cannot really change a door location. It's really supposed to be static and interconnected. That's it. The job is not to model. Job is not to edit a model. So it doesn't do the jobs that a 3D software does. Okay, that's the current step, right? But the software that is used most extensively is called Synchro. That's where it's really started. It is used more efficiently because it is really built from a 4D perspective, and it has a better rendering engine. I think it just has a better visual representation, a rendering engine that people like to see. and that's why it is used. Now, with the visualization, SketchUp is becoming very common these days, right? What people do is they're not necessarily getting a detailed schedule, but let's say they're trying to bid on a project, they'll get into SketchUp, they'll build a quick model, block model, don't get into details, quick schedule, and they'll connect with the SketchUp model. And what it does is, in a matter of few days, you have a fantastic model of how you want to build a building. It's very big picture, it's not detailed, it's not supposed to get into the manufacture level or the detail level that 4D is really intended to do. But this is very high level pre-construction analysis that you could do using SketchUp. So that's why I kept it very down. These two guys are used but don't have very high penetration into 4D. That definitely good softwares. But mostly often when you see 4D, you'll see these two guys, Navisworks and Synchro. And Synchro by far is in my opinion, a better tool for 4D because it has a better rendering engine. It has more user, the user experience and the end user experience is much more prominent or better in Synchro, just with the rendering engine. With that, I would like to thank you all for joining us on this webcast. We'll be doing more of these in coming weeks. We'll have mostly more speakers coming from what I hear from the NIBT folks. And thank you for joining. If you have any questions, feel free to email me or email NIBT folks, and they will definitely let me know what your questions are. Thank you very much.